Hello, everybody. Good evening, and welcome to our presentation today. My name is Sicoya Bellis. We're here as part of the North Seattle College Rocketry team, and we have some guests to share with tonight's presentation. So I will be talking about launching success, how student clubs support STEM education and careers. So a little bit about me. I'm from Seattle, Washington, USA. I run the North Seattle College Rocketry Club, which is a student-led club at our community college. And I am currently a student. I'm in my second year. And yeah. So what is high-powered rocketry? High-powered rocketry is essentially a hobby where we build rockets using big motors that can go pretty high in the air. The main goal of our club is we get members certified through nationally recognized associations of rocketry. In our case, we specifically acquire the National Association of Rocketry certification, the NAR. And these certifications have many levels, or have 3 levels technically, from the level 1 rocketry to level 2 to level 3. A level 1 rocket typically goes about 1,000 meters in the air and weighs between 3 to 5 kilograms. Level 2 rocket goes anywhere from 1,000 to 10,000 meters in the air and can weigh anywhere from usually 5 to 10, 15 kilos. And then like a level 3 rocket, that can be all sorts of things. They get really big at that size. Very exciting. So what our club does is we bring in members from all over the community. It can be anyone from students, just people who are interested in the hobby, or really just anyone who wants to learn how to build rockets. They're welcome to our club. And what we do is we provide new members with these prefabricated kits known as rocketry kits. And they're able to learn a bit about the basics before really going off to explore some of the more complex aspects of rocketry and specializing in sort of what they want to do. And that's what's so great about our club is it's a great place for teamwork to happen, for people to learn and really continue to explore the hobby. So there's many aspects of rocketry. First, there's an aspect of project management. We need to, depending on the complexity of the project or the rocket, you need to know everything from people's availability, what materials are around, how to order and supply things, who wants to do what, who can do what. There's a lot of complexities when you're dealing with these sort of volunteer organizational or volunteer and student options where you have to have a lot of flexibility with whenever you have a big project you want to get done. And in that same vein, we pull in a lot of areas of expertise for building rockets. Sometimes students will be really interested in fabrication and want to learn how to 3D print, 3D model. They might want to get into laser cutting parts, or maybe some of them even have access to a machine shop and can bring in metal components that are otherwise very difficult to obtain. And then there's entirely other areas that our members might engage in. Some people are interested in learning how to build rocket fuel, and so they get a little bit of practice in chemistry. Or we have members who are really interested in programming and building electronics and getting that hands-on experience of actually soldering all the components and testing them, making sure they work. And that whole sort of, process of putting everything together into one package is really great for the development of our members and our students. And this is just one of many clubs that our campus and many others offer. The great thing about student clubs is the goals are student driven. There's no curriculum that necessarily has to be followed. It's about students following their interests, their passions, and really going where they want to go in the world and doing a small part of that while they're still in school. And they're able to, it's not just limited to students, other members of the community can come in and also share their expertise, which is great because you get some of that outside knowledge and experience into the into the sort of student population where it's a bit of a bridge from the academic and the real world. And so that's what else is. There's so many different subjects that students can explore. The amount of subjects are as diverse as the number of students. I know in our own school, we have everything from rocketry to K-pop to, no, there's all sorts of them. Chess clubs, you name it, there's something. And every time I look, there's a new club starting. Another great aspect of these clubs is we're able to share opportunities with each other around the things we are interested in. I know that we often post scholarships, internship opportunities, volunteer opportunities. Anything that a student needs can be shared, so that they have these, so that they can go out and get the experience they need to really figure out what their path is in life. I know too, we also have meetings with different chapters and the engineering council, and there's also larger organizations that we are attached to. And most importantly of all, we're a welcoming space. We want people to join, we want them to learn, and we want to be able to provide that expertise and knowledge to everyone who is interested. And another important aspect of our clubs is that we have club advisors who are both experts in the field, but their role is to guide the students and to finding their own path, right? They provide continuity to the club. A good club advisor can be there for many years, so that as the generations of students move on, there's still at least someone who has some idea of how things should work and how to get the procedurals out of the way, and really just how to sort of navigate the complexities of working in a system, and also how to find the tools you need to get done what you want to get done. And so in this picture here, we have our club advisor, Tracy Furatani, and then we also have one of our partner clubs, Sergey, from Amir State, Sergey. So that's another great part of what we do, is we are interested in collaboration and sharing with people from all over the world. Right now, we're actually broadcasting from Seoul due to an opportunity where we were able to make contact with the Seoul National University team and the Amir State University team from Russia. And so just one of those cases where when you put yourself out there, you're able to go places you wouldn't have expected for reasons that you never would have planned for. So that's a big part of what we do, is we try to find people where we can just talk with about rocketry, learn about rocketry, and really just sort of move forward with expanding our domain of knowledge. So a big part of what we're doing here is we have a collaborative project where our 3 universities got together and decided that we wanted to build a 2-stage rocket, and we named this project the ARC project, standing for America, Russia, and Korea. But this is a pretty awesome opportunity because 2-stage rockets are very complicated. There's a lot of moving parts, and all 3 of our clubs have different restrictions and challenges to procuring supplies and materials. And we have been working together to troubleshoot our problems and prototype what a design might look like. And at the end, we're hoping to find a common design and a common rocket that will be available for all 3 of us to actually, work together and build and contribute components for. And this comes after a long time. Well, I'm going to go back and give a little history of our club. So our club itself started in 2014 or so. And in 2017, our club advisor, Tracy, got into contact with the Amir State University's club advisor, Sergey, and they decided that we would have a collaborative project with each other where we would both build 2 components of a rocket. So often the 2 most difficult parts of a rocket are the rocket body itself, and that looks something like this. And then, oh, we got full screen here. Sorry, guys. That looks something like this. And then the other complex part is what we call the avionics package, which is all the electronics and the power supply and all the wiring that can do more than just mechanical operations, So when we build these rockets, there's several main components. We have our motor, which is what holds the fuel in it. We usually use a solid fuel for these rockets. Liquid can be done, but it's very complicated and outside the time budget of most students. Usually, so we have our solid rocket motors, and often part of what we need for a successful launch is we need to launch the rocket, and then we need to recover it again. Because if your rocket cannot be flown after you launch it, it is usually not considered a successful launch. So part of the challenge is not just in building something to go up, but something that comes down slow enough that you can still recognize what it is when you find it again. So part of how a rocket goes is you have your motor, it goes off, and then you need to deploy parachutes. And the bigger your rocket, the more parachutes you need. So that might mean you'll need timing devices to decide when you deploy a parachute. Because if you launch them all at once, you have a rocket, 5-10 kilometers in the sky. And if it's going really slow, it's going to go really far. And so that's the sort of issues where you might deploy one parachute and then 10 seconds later deploy your next, and then several seconds later deploy your third. And to do that, you need electronics to know both where it is and sort of what speed it's going at, and then you need it to cause a separation event, which that is usually done by exploding some black powder or something similar so that you can create a lot of gas to push two pieces apart. So that's a lot about what we do. Is we try to bring teams together, and tonight we have both our Amir State University Rocketry team, and we have our Seoul National University team. And then we also have another speaker who's a former club president of ours, Alex Langenstein, and she will have something to talk about right now.
All right. Thank you, Sicoya. Yes, I'm Alex Langenstein. I'm the previous president of the Rocketry Club at North Seattle College. And I actually would like to talk a little bit about there are alternative paths to working in the aerospace field. I actually, after being involved with the Rocketry Club, went on to work in the private space sector, not as an engineer, but as a technician. And I really want to highlight to students that you don't necessarily need to become an engineer to work in aerospace. Some of the skills that we see from students that come from different backgrounds and are going through a career change or going through job changes or just going back for more education, their life skills really apply to all of the intricate planning and things that need to happen to build a rocket successfully. So some of the skills that are really important are fabrication skills. The hands-on experience that you get from building a rocket is really just so important, and you can't really learn from a book necessarily. Getting those hours in, some of the most impactful students that we've had came from machining backgrounds, came from welding backgrounds. So those are skills that in the aerospace field are very, very highly prized and valued. So these are things that also need to be taken into consideration by engineers. There are so many impressive engineers in aerospace, but if they design a part that cannot physically be made to the specifications that are needed for its application, it's not going to be helpful to anyone. So having good channels of communication between engineers and technicians, the people that design parts and the people that create the parts, is really essential. And that's a big part of this project as well, is being able to have an engineer design something and go to the student that has the machining background and say, hey, how do we make this part? What's the best approach? So being able to respectfully understand each other's backgrounds and our goals, and trust each other in what needs to happen to finally assemble this rocket is really important. And it's been an amazing experience meeting with the Amherst State University team, working with the North Seattle College team, and then also now with the Seoul team. Everybody speaks the same language. Everybody needs to be able to collaborate together. Building things together and having these different perspectives is really key. I actually started with the education plan to become an engineer, but as I got into it more, I found myself more drawn to the building and the hands-on aspects. I actually went into a program called Mechatronics that is for people that want to go into a huge array of different jobs. So I studied electrical engineering, mechanical engineering, and computer science, and was able to stitch together those three aspects to work on very advanced machinery. While working at the private space sector, I actually excelled in additive manufacturing. So my background is now additive manufacturing for aerospace, specifically with metals. So we don't really build many metal rockets in our club, but a lot of the same principles and skills still apply to whatever material. And I think most importantly, being able to communicate with everybody on every team is a huge aspect. I think I'm going to hand off to Tracy.
Thank you very much, Alex. And that was a great summary of an alternate career pathways. Really appreciate you talking about that. Mr. Moderator, or tech support person, can you get rid of the slide so we can see each other? Thank you. There we go. Okay, now I can see you all. Wonderful. Thank you for coming out tonight. And I would like to point out that I have a couple of sets of comments. One's directed to the students, one's directed to your teachers. And for the students, how many times do you get in a class where you or have an activity where you're allowed to fail? This is what's great about class. The fact is that, I teach physics. That's my day job. And I feel terrible when students don't understand the material, but I have to assign a grade at the end of the day, just like you get. And the problem is that, sometimes it's not as good high a grade as you'd like, and it might have some impact on your future. At a club, when you build the rocket, if it doesn't launch successfully, it's okay. It's part of your learning process. There is no penalty for failure. So this is a wonderful thing. And the ability to do this while you're in a club and not while you're at your first job or at graduate school, that's amazing, right? And that's really why I want you to join the club. The other thing is that how many times have you thought about a topic in a class like physics or chemistry or biology where there was something really interesting you wanted to pursue? Like, for instance, in my physics class, people often ask about rocketry. And of course, I can talk a little bit about it, but I can't talk in depth about it. And in a club setting, we can do that, and it's a lot more fun. So if you want to talk about weird hybrid motor rockets that you want to build, that's when we can talk about it. We can't do it in physics class. So another reason to join a club is you can talk about whatever you're interested in more deeply. And as Sicoya pointed out, it doesn't have to be rocketry. You can join a chess club, if you join computer science club, you can talk about these other topics that really interest you and be able to pursue some of this stuff And it's really amazing to be able to do it with a bunch of people who think like you, who think those are cool problems. The teachers. One thing I want to point out is that this is a great way to get to know your students better, because you're going to get those students who are really interested in a topic that you're the advisor for the club for. And so I get to talk with my students about rocketry, which, I can after class and before class a little bit. But face it, we have about an hour or two a week that I can just talk about rocketry with a student. It's a lot of fun. And you notice what it leads to. We have these international opportunities now. You can connect students with a larger community of scholars who are interested in that topic. And for that reason, I really encourage all of you teachers out there to find some pet passion that you have, that you can actually apply your extra knowledge to better the students' knowledge on these kinds of topics. So you end up with basically these opportunities. Like I was able to go to Amherst State University and meet my friend Sergey Yanenko, who's basically the advisor for the other club and then for the Amherst State Club. And I think that was truly a turning point in my life, because not only did I get to experience what a club in Russia was like, but also what life in Russia is like. And it's been it's been a great exchange. He has been able to come out to the United States and be able to experience some of that. So that's really kind of neat. And now with our new partnership with Seoul National University's team, we hope to replicate that process, where they'll come over and hopefully all three teams will join up sometime next summer to launch this two-stage rocket that Sicoya was showing to you. That would be amazing. I don't even care if it blows up. I just care the fact that everybody is there and watching the results of their efforts finally come together. And that's just such an amazing feeling. I hope you all have that. And so speaking of our Hanara team, our Seoul National University rocketry team, I'm going to turn it over to Dojeon, and he's going to tell you a little bit about what they do.
Yeah. Hey, moderator, can we share screen here?
Hello everyone. I'm Dogon Ra, serving as the president of the Seoul National University Rocketry Club. And here with me is Gwen Yang, one of the two vice presidents. Today we are here to introduce our Rocketry Club and express our gratitude for inviting us to this fantastic collaboration opportunity. First of all, let me introduce who we are. We are the Rocketry Club of Seoul National University, founded in 1998. With a total of 70 members, about 20 of which are actively engaged in our activities. Excluding the year 2021, during which our activities were hindered by the COVID-19 pandemic, we have been actively participating in the Spaceport America Cup in 2017, 2019, and 2023, showing gradual improvement and promising results. Here are our rockets. On the left is a rocket named Haram, designed to reach an altitude of 10,000 feet using an M-class motor. Through participating in the Spaceport America Cup with this rocket, we learned a lot. This is another reason I look forward to this international collaboration project. On the right is Identity, a domestically launched rocket designed to navigate through various legal regulations arising from the characteristics of a divided nation, reaching an altitude of approximately 200 to 400 meters. Pretty wide range, right? It's a rocket flown at lower altitudes, but we optimize and apply the knowledge gained through technology exchange. I can't imagine how it will change through this collaboration opportunity. And from here, Gwen Yang will continue by introducing the main activities of our club.
Thank you, Joe. So we actually conduct various supplementary educational programs that aren't taught by our university students. So one of it is numerical analysis. So on the left, you can see the free from an aeroelastic analysis of the rocket fin. And on the right side is just an analysis of the force of the pressure field around hexagonal fin when it is oscillating in the air. And we also teach basic CAD, basic CAD design, computer-aided design, and also system education, because rocket is an integrated system after all. It has multiple mutually interacting subsystems. So like intersystem cooperation and conflict resolution, and also resource and schedule management is very important in building a rocket. In real life, it actually just means lots and lots of arguments and like late night Zoom meetings, but that is what it is. And then, yeah, there's a bit of a buffering, but yeah. So you go through all these steps, and if you, the mic is muted. Oh. I'm sorry. Anyway, yeah, if you are lucky enough, you get to launch a rocket like we did in 2023. So, why does student club matter? So, it's supplements the lack of, yes. So it's supposed to supplement the lack of practical education in our school's aerospace curriculum. So of the mandatory courses, I think we have around 20 mandatory subjects, but only a few of them allows us to actually build anything ourselves. And none of those actually has us building an integrated system. So system engineering, human engineering, cooperation, all these that we get to experience in building a rocket helps us become a well-rounded engineer, a useful engineer. And we also got to learn the Rocketeer spirit, like international solidarity, and yeah, we will talk about it later on, but yeah, we experience a lot of support and help from other teams. Well, in Spaceflight America 2023. And above all, it's a special memory that we will be carrying on for our lives. University is not just about, getting good grades or getting good parties. So it's something meaningful that we can do. So for us, this collaboration started when one of our alumni, Yu Ganghyun, was contacted by Anna State University. So we got to learn about the ongoing project that the two teams had already started through several Zoom sessions. And yesterday we were able to share our insights and technological advances, as well as discussing the specifics of our future collaborative project at the offline hangout. So we learned that we take some drastically different approaches, and we have different ideas about certain subsystems, but we also learned that we have this shared love of rockets, which is what really matters. So yeah, we feel grateful for this experience. After all, it's not a common opportunity for like an undergraduate engineering student to, hang out with students from other countries, and especially from the big two in the airspace. So we would like to thank Professor Protani and Professor Yanenko, as well as Yu Ganghyun and everyone else who made this possible.
All right.
Yeah, well, back to the.
Back me?
No.
Sorry, technical difficulties.
So at Sicoya, we experience international solidarity. So like if the New Zealand team, the slideshow is actually not showing. Oh, okay. Yeah, so if the New Zealand team who taught us how to assemble our motor, and it was the Mexican team who actually very graciously lent us their flight computer when ours broke down. And well, there were some like safety advisors who stepped up to like help us build our own finish up a rocket at the on site, and also our L3 supervisor was shared with the Quebec. So it was a manifestation of international solidarity and friendly competition that is frankly quite hard to see in domestic competition. So isolation leads to stagnation, and we cannot afford to stagnate, especially in aerospace, like aerospace industry, where everything, because it's so closely linked with the national defense, it can be hard to cooperate internationally, like due to geopolitical reasons. But this is why we hope this friendship among the budding future engineers can cultivate the atmosphere for
Thanks for your comments. I really appreciate the spirit with which you entered into it. It's wonderful to see. Very refreshing.
Yeah, and thank you everyone who presented tonight. As of now, do we have any questions in the chat? We'd love to answer anything you guys want to know about related to rocketry, clubs, America, or other things that were brought up.
Oh, Korea or
Russia, yeah. Anything. So rocket bodies can come in a variety of materials. In the situation with this particular rocket, it is made out of fiberglass with a plastic nose cone, fiberglass body, and plywood fins. And the primary method of attaching everything is a two-part epoxy. However, we can use all sorts of other materials in our rockets. Sometimes we make them out of cardboard. Even metal rockets can happen on occasion. I know our Hanaro team has to source a lot of their own rocket body parts, and they're using 3D printed resin fibers to do that. Do you want to talk a bit about how you build your own rockets, Glenn?
Well, we also use a lot of fiberglass, but some of our fuselage is actually made out of carbon fiber, which is a lot sturdier and also lighter. And then we, as Sicoya just mentioned, for some more complicated parts, we also use 3D printed cotton, 3D printed FRP materials. So that usually goes into our recovery system.
Yeah. And then there's some miscellaneous other parts we might use in our rockets. Sometimes like we have different attached to parachutes, we'll use shock cords, parachute cords, or even Kevlar cords if there's an area that we expect to get really hot because we don't want things to melt and burn away. So there's lots of little elements that come together to sort of put together a rocket. And depending on your constraints, whether it's weight, supply, or just sort of what you have sitting around available to make something out of, that's largely what depends on what you build, how you build it. Any other questions? Yes. So, we primarily use a program called what? Oh, So question, are you using open source software for the simulations or the licensed programs? So yeah, we primarily use a program known as Open Rocket that is very convenient for simulating your rocket designs before you build it. When you build a rocket, there are several factors you want to consider. So there's one concept known as the center of gravity, which is essentially where the rocket weight is distributed 50% on one side and 50% on the other. And you need to compare that to the center of pressure, which is much more complicated to calculate and is one of the primary reasons we use the simulation programs. And what that essentially tells you is the point at where it's stable. And you need what we call caliber, which is the thickness of a rocket. You need anywhere from 1 to 2 calibers difference between the center of pressure and the center of gravity. And so we often simulate our rockets in this program called Open Rocket, and it also tells us about how high it's going to go, and we can even factor things in, like if we have a 2-stage rocket, if there's a delay between the second stage launching, it'll adjust for all those numbers, and it's a very, very convenient and very helpful tool for that. And it's open source, which is even better since
It's free.
yeah, it's totally free. Yeah, so anyone can kind of check that out if they want to play with rockets. It has lots of example designs as well, so anyone can go in and sort of fiddle around with things until they figure it out. And it has support for many different languages, which has been important for us since, for example, of our ARC project, our Russian Amir State team, they sent us the design in a different language in English, and we then had to figure out how to translate many of the parts, which is always a fun process and really helps test our knowledge what part is which when we're looking at it. Another question. What are your career plans? What opportunities are there in Korea in the rocketry sphere? Do you want to take that?
What are your career plans? Is this, I don't know if this is supposed to be quite a general question or a career specific question, but for us, well, so the thing about aerospace engineering is that it's actually quite versatile. You don't have to go into aerospace engineering after you've majored it. So some of our alumni are working in car industry, others are working in manufacturing. So there is a multitude of plans. I personally am going into academia, but that's just me. And what opportunities are there in the rocketry sphere? So there are some domestic aerospace startups going on. So it has been quite a boom. And also the government has in plan the aerospace ministry or something. I don't know how it's translated to English exactly, but yeah. So there is also a government body in plan, so in blueprint. So that is another option, I would say.
And, often in our club, career plans are quite diverse. I know I myself am potentially looking at becoming a psychologist. I'm not even necessarily going into rocketry or aviation, but I just love the field, and I love the idea of, humanity reaching for the stars and trying to, get up into the sky. So yeah, that's what's so great about these student clubs, is it provides the opportunity for people of any walk of life whose classes might not even be related, and yet they're still able to come in and explain it. Sorry, just a moment here. All right, can we get Tracy or Alex on?
All right. So, question for Alex: what does a technician do? So, this is a really interesting question. A technician is a very general term, but it is anyone basically that does something to help move the project forward. So a technician can be someone that's setting up testing rigs for test engineers to test things. A technician can also be a welder. They also can coordinate a lot of things. So making sure that material is arriving on time and getting to the right place, to the right person, things like that. It's a huge array of things. They're also the people that they call when the rocket is stuck on the pad for launch. They are the ones that are turning wrenches. They are the ones that are getting their hands dirty. They're having generally a lot of fun doing it. So hope that answers your question. Thank you.
Question, is MATLAB Simulink a frequent tool in the stability and control analysis? So I'm less familiar with MATLAB Simulink myself. I don't know if anyone else here can comment on it. However, I do know that it can be used. It's just, I think it's a matter of preference and what you have experience with. It's kind of, at the end of the day, whatever tool you learn is the one that will be most effective for you since you've taken the time to learn it. So if you want to learn that, I would definitely go for it, since I know MATLAB has many diverse capabilities and being familiar with it is great overall. Question for Tracy.
Right. I'm not sure why I'm not showing up on screen, but there we go. Thank you. The question is, what are some key factors that contribute to successful international collaborations among student clubs? How and where to find these opportunities for Russian clubs? And that's a great question because I don't have a very good answer for that. For instance, the initial collaboration with North State has happened as a result of my college president getting a Fulbright scholarship to study in Russia for a season. And as a result of a collaboration amongst different college presidents, he was able to make contact with the North State's president. And the one program that seemed to be of interest to both was the rocketry program. That's how they recruited me. So the key factors really are, you have to have an engaged college administration. You have to have engaged college faculty or high school faculty. My experience is college, but of course the same thing holds for high schools as well. And also you need to have engaged students. Clearly, without the students, there's no reason to try to set up a program and force students to do it. So I think it's kind of understanding, it's like reading the room. It's like saying, okay, here's my student body, what they seem to be interested in, what kinds of collaborations, therefore, should I be pursuing? And that's really the tricky part, because student populations, let's face it, are transient. At a college, they're there for 4 years and then they're gone. High school, 3 or 4 years, and they're gone. My college is worse. It's a 2-year college, so 2 years and they're gone. So from year to year, you may have wildly varying things, but if you establish a really good reputation, then that reputation kind of carries you through the lean years. So I have been an advisor for our club for about a decade now, and I've seen different numbers of students being engaged. And I think that the key thing that they all have in common is that they have this desire, this passion for doing rocketry. And there's always at least 2 or 3 students who can form a very good core, and then they draw their friends in, which is kind of neat. They draw their classmates in from other classes. And so I think that's really what you have to encourage, is have an environment where it's safe for people to want to explore these kind of new ideas they have. And even if they fail, as I said before, that it's okay, but they're just learning, you're learning how to do these kinds of things. So I hope that helps.
All right, question for me. Sicoya, what struck you most at Seoul National University and Seoul in general? I think one of the most biggest differences between here and my home is just how sort of organized and tidy everything is. Like, it's really impressive how quickly people can get into sort of lines and coordinate getting on and off even just the metro with so many people, more than I've ever seen in one place. That part really struck me as sort of unique to this area. And then the campus itself was incredibly clean, and everyone was very respectful. And the layout was very sort of open and peaceful. And it definitely had a good feel to it at Seoul National University. And when we went into engineering building itself, I found it interesting. It was cool how there were all sorts of little like projects. Like there was a series of lockers with a bunch of RC cars on top that were all looked like they'd been custom designed by engineering students. It was just cool to see little things like that. Another question: what flight computers do you usually use in L2 to 3 rockets? So in my experience, I don't know if I can say I usually see a specific computer. Every rocket I've seen has had something different. However, the most common things are people use Arduinos or Raspberry Pis. And then often we connect various components to those. So there'll be an altitude sensor, an accelerometer, a barometer, a temperature sensor. Sometimes people attach cameras and SD cards to store the information. So there's lots of different pieces that go attached to our flight computers. So a lot of them are hand built. And then there's even ones that can be custom bought. But those are often almost a seasonal item because only a limited number of flight computers are built. And then you have to, next year, there'll be a new one that's built. And so you just kind of get what you can find. I know for this rocket, we tried to build, or for our ARC project rocket, or at least our first version of it, we tried to assemble our own flight computer from essentially a kit, which meant we had to solder every connection on a little teeny tiny little circuit board. And we'll just say it was quite a challenge since we didn't quite have the tools equipped to do it. And in fact, we're still working on that. So we'll see how that ends up before we get there.
I also make a comment in too. Okay.
Go on.
Also at Space Force America Cup, you are going to see there are a lot of teams that build their own avionics. We call that SRAD, that is Student Researched and Developed Rocket like avionics. So you see that, and also there are some pre-made flight computers such as I've seen Blue Raven and Egg Timer. At first, like I read the word Egg Timer and I thought of an actual egg timer. So it took me some time to realize that it's actually just a brand name. And also there are beacons that you can put in as well to look up, just in case you lose connection, so that you can actually find them later by GPS.
All right, question. What is the most memorable memory from the collaboration between Muir State University and North Seattle College last year? So last year we had a project where we worked together so North Seattle College built the avionics package. And from my end, I helped a little bit with that. And I remember just I think it was just about a week after final or weeks after final. And we were like, man, we really need to get this all built. We had all the pieces. And there's that just last minute scramble of where we tried to figure out, hey, who can solder this? Who can figure out how to program this? And just that sort of last minute chaos where we all sort of got together and buckled down to get it built and assembled and find all the pieces and make sure it all fits together, and then finally get it sent in the mail over so that the other team can actually make use of it for their rocket.
Yeah. And previous to that, we had when the Alma State University team visited us the first time, getting everybody in one place at one time and taking our rocket out to the launch site was really incredible. Having both teams finally together after working through the pandemic over Zoom calls for so long, that was really an amazing experience. And it was so stressful. It's not aviation, it's not aerospace if it's not stressful, especially in the last few minutes leading up to your event. But when you go through something that is that stressful and that high stakes, when you come out of it at the other end, you have a bond that you've built with this team that is a real lifelong bond. And after that very stressful event, we then had our culture week where, oh my goodness, we went to every single tourist spot in Seattle. We ate so much good food. We went on every tour. We did all the things that you can do. And going through those things is just more memories and more good things to do with friends. So I think that's the most memorable. Yeah.
So question, are there any rocketry club competitions in Russia and Korea? From what I understand, Russians and Koreans went to the USA to launch the rockets at a competition. Are these competitions widespread across America? So I'm gonna have to ask our Russia team, do you guys have many competitions out there?
Hello, everyone. Yes, in Russia we have about 3 competitions that take place all around the year. I may list them. I think the first one is like Reактивное движение, which is held annually in Kaluga city. We participated in those competitions like twice and took 3rd place, if my memory doesn't betray me. Also, we have another competition that we never took part yet, but maybe we'll do it in the forthcoming years. So this competition is called GIRD, and it has several leagues, and the really top teams from Russia participate there. And also we took part at competitions in Samara, which held by Samara Aerospace University, which is our great partner and close partner. So we participated in those competitions too, like several times. So that's mostly what competitions are held in Russia.
Great.
And now about Korea, there is a university rocket team association. It's called Lunar National University Rocketry Club Association. So it holds rocket launch competition every year, but there are some restrictions that come with the military and stuff. So it can be quite difficult. So we are only allowed to use solid fuel and only some types of solid fuel, and it can only go up to around 300 meters. So the Spaceport America Cup is basically our only opportunity to launch a larger scale rocket.
And I'd like to add one thing, which is, in addition to Spaceport America Cup in the U.S., there's also the International Space Modeling Competition, which is more theoretical, but nevertheless, it gives you an opportunity to explore rocketry. That is held in different countries in different years. In the U.S., NASA sponsors something called the Student Launch Initiative, SLI for short, and that I think international students can work, but unfortunately the international teams cannot compete in because it is a U.S. government thing. So there's different kinds of competitions, and the one thing that is also true in the U.S. is there are open launches where different clubs across America, as Sicoya mentioned, there's a thing called the National Association for Rocketry. There are different clubs that are affiliated with that main organization, and each of those clubs can sponsor its own launch. And so these are open to the public. You pay a fee, you get to launch. You have to prove that your rocket is, of course, flight worthy. And the idea is that if you were to come over and make arrangements, especially with some of the larger rockets, you would have a good chance of being able to launch there too. So it's not a competition, but at least it's some way to get it launched.
Yeah, so and just to add on to that, like our own club chapter, local chapter hosts an event known as the White Swan Launch, where we and a couple other organizations get together usually 2 or 3 times a year and have a launch out in the middle of nowhere, where we try to walk between the cow skulls and find our rockets after they go off. So that's part of the challenge, is you have to be in areas where we have approval and where we're not going to get in the way of airplanes or people and other important infrastructure. So next question. how to build a reliable rocket from scratch if I don't have any experience in rocketry. So this is something I can actually kind of talk about. So in my case, my first rocket was built from a kit, but my level 2 rocket I have built completely from scratch. And I would say there's probably about 4 main things you need to build a rocket from scratch. You need 2 types of pipes, not really 3. Give it a moment here. So if you look closely, you have your main diameter pipe, which is a little bigger, and then you have a smaller diameter pipe that's just big enough to act as a coupler. This is a sort of very basic way so that you can attach 2 pieces together. And seems a little difficult right now. There we go. And they'll just go together like that. So you need 2 pipes that just barely fit together. The inner diameter and outer diameter pipe. And then, as you see, we have a shock cord in here. And eventually, I will attach a parachute to that. And then that is, again, attached to the top and bottom parts stably. We also have fins. In my case, I used a tool. We have fins on these. I used a tool to cut out a channel in here, and I glued I epoxied the fins to an inner tube known as the motor casing tube. And then that tube is attached to the outer body via centering rings. Yeah, there we are. And so pretty much it's just a couple tubes, some plywood, a smaller tube that fits your motor. If you're in the USA, motors are sold in different sizes, and you'll want this motor tube that runs through here to be the right size and diameter and length. And then I'm not quite sure how it works in all the other countries, but I'm sure that if you can find, there's probably information online to look that up as far as what's available to you. And so for the most part, that's most of a rocket. And the last part you really need is a nose cone. And these can be hard to manufacture, but that's more or less the process of building a scratch rocket.
Some people use like a 3D printer for that sort of thing.
Yeah. Anyways, I'd like to thank you guys tonight for coming out here. It's been a great opportunity to come on this trip and speak to everyone, and I hope that everyone learned something. And maybe you guys will be inspired to start your own club, whether it's in rocketry or anything else. And so thank you from America, Korea, and Russia.
Keep talking.